Good day all, and welcome once again to my channel. Today we are going to be having a video lesson on the naming of alkanes, alkenes and alkynes. Now this group of organic compounds happen to fall under the aliphatic hydrocarbons, of which I've explained that in one of my previous videos. I explained about the hydrocarbons, letting you guys know about the two divisions of hydrocarbons, aliphatic and aromatic. So this group of organic compounds, they fall under the aliphatic, alright? So we are going to look at how we can name structures. This aspect of organic chemistry, when some students, they are confronted with it, it becomes so challenging to them. So it's with my hope that immediately after this video, you'll be able to name organic structures with ease, alright? So let's dive into looking at it. Firstly, we are having the rules that we need to obey. Some set of rules that needs to be obeyed before we can get the correct name of an organic structure. On the board we are having about 5 of them. The first is that we identify the parent chain, which is the longest continuous carbon chain. And the second is we identify the substituent. The third is you number the parent chain in both directions, talking about the longest continuous carbon chain, which happens to be the parent chain. Then fourth, you give the least possible value to the substituent if they are present. It could be more than one substituent, alright, so bear that in mind. Then number 5, separate numbers from numbers by comma and numbers from letters by hyphen, alright? So one thing that you need to know again, don't forget this, that the full meaning of IUPAC is International Union of Pure and Applied Chemistry. Alright, so that's the full meaning of IUPAC. Now, this is the secret. Whenever you are confronted with any structure, you must obey the rule 1 and rule 2. You must know it very, very well. And how do you go about it? Identification of the parent chain is of utmost relevance because you should know how to get your longest continuous carbon chain. And I'm going to give you guys the secret on how to go about it, so as for you to be able to get your longest continuous carbon chain, which happens to be the parent chain. And mind you, the parent chain is not usually horizontal. It doesn't really take that horizontal pattern all the times. It could be having branches. So that's the essence of me understanding how to identify the parent chain. So we are going to start by looking at naming of the alkanes, and then we'll now forge ahead to looking at the alkenes and the alkynes. But mind you, you ought to know that the alkanes are saturated. The alkenes and the alkynes are unsaturated. What does that mean? It means that the alkanes, they are characterized by their carbon-to-carbon single bond. Then while the alkenes, they are characterized by their carbon-to-carbon double bonds, while the alkynes are characterized by their carbon-to-carbon triple bonds. So if therefore implies that when you have a particular structure and then all the carbons are connected or linked by single bond, then just know that is an alkene. Then when you have your alkene structure, you are having carbon-to-carbon double bonds. When you have carbon-to-carbon double bonds in a given structure, you know that that is an alkene molecule. Then when you have carbon-to-carbon triple bonds in a given structure, you can tell that that is an alkyne molecule. Alright? Another very beautiful thing that you need to take cognizance of is in terms of your substituents. Now the substituents can come in the form of elements. It can come in the form of groups, organic groups. By organic groups, I'm making references to the alkyls. The alkyls. Most times, the alkyls, they function as substituents. When I say alkyls, I'm simply referring to a group that is formed from alkanes. When alkanes, they lose one atom of hydrogen. So when one atom of hydrogen is being lost from alkanes, it gives you what? Alkyls. And of course, if you have the first member of the alkane to be methane, and you already know that the formula of methane is CH4, then it means if you want to get a member, a corresponding member under the alkyl group, it should be written as methyl. You get? So methyl. What did I just do? I replaced the ANE with what? With YL. Alright? And then what am I supposed to do to get the formula of methyl? It's very easy. Like I said, these ones, they are formed from the alkanes by the loss of what? One atom of hydrogen from the alkane. So it therefore implies that if I should remove one atom of hydrogen from methane, I'll be left with CH3. So whenever you come across this formula CH3, know that it is for methyl. Alright? Same thing goes to the other members. Remember that ethane is the second member of the alkane series. Its formula is C2H6. How did I come about C2H6? Homologous series. That each successive members, they differ by what? By CH2. And what does that mean? It means successively, if you want to get their respective formula, you should increase the carbons by 1 and the hydrogens by 2. Alright? So the difference between this and this is actually CH2. You get the point? So if I want to get a corresponding member under the alkyl series, it should be written as ethyl, which is C2H5. How did I get my C2H5? Very easy. I simply subtracted one atom of hydrogen from ethane and then gave me C2H5, which is ethyl. Alright? So that's how you get it. So these ones, they actually function as substituents in organic compounds. Alright? So take cognizance of that. Then you could be having elements functioning as substituents, like you could be having chlorine, Cl, you could be having bromine, Br, you could be having fluorine, F, you could be having I, which is iodine, and others, alright? So when you have chlorine seated in an organic structure functioning as a substituent, you don't call it chlorine, you call it chloro. For this one, it's not bromine, it's bromo. For this one, it's not fluorine, it's fluoro. While this one is iodo, which is not iodine, when it is seated in an organic structure. A very important thing that you still need to take note of is when you have already identified your parent chain, you must know the prefixes that you should use. In terms, it starts with the alkanes, the members of the alkanes. Remember that the first member of the alkane is methane, so that met is for 1 carbon. Ethane, being the second member, eth there, which is a prefix, is for 2 carbons. Then prop is for 3 carbons, but 4 carbons, pent 5 carbons, hex 6 carbons, hept 7 carbons, 8, which is oct, then 9 non, then 10 dec. That's how you get it. So it's that easy. So we are just going to start by looking at naming of the alkanes. On the board, we are having 2 structures of alkanes, and we are told to provide their names. So how would you go about it? Firstly, don't forget, remember what I said, that 1 carbon is met, 2 carbons et, and the rest of them, alright? And then another thing that you need to know, before you can identify your parent chain here, because in this case you're having branches, what are you supposed to do? Please, you must know this, that there are actually 4 kinds of carbon that we have in organic structures. And what are these 4 kinds of carbon? Please pay attention. We have the primary carbon, the secondary, the tertiary, and the quaternary. I repeat again, the primary, the secondary, the tertiary, and the quaternary. What do I mean when I say primary carbon? I'm simply referring to a carbon that is directly connected to just 1 other carbon. When I say secondary carbon, I'm referring to a carbon that is connected directly to 2 other carbons. When I say tertiary carbon, I'm referring to a carbon connected to 3 other carbons. Then when I say quaternary, I'm referring to a carbon that is connected to 4 other carbons. And what does that mean? It simply means that if I have this kind of link, like this one, this is a primary carbon because it's just only connected to 1 carbon. This is also another primary carbon, it's just only connected to this carbon. But if you look at the one at the middle, it's connected to 2 carbons. So you call this secondary, this is primary, this is primary. So that's how it works, alright? So now with that in mind, what is now the next thing? What about for tertiary? If I want to go with tertiary, it means that I will have to link this one to another. So in this case, if you look at this carbon, it's connected to what? To 3 other carbons. This one is primary, this is primary, this is primary, this is tertiary. But if I happen to link this to another carbon, then this becomes quaternary. This is 1, 2, 3, 4 connected to this guy. So that's how it works. So my code is this. For you to be able to identify your longest chain, you will have to dot the primary carbons present in the structure. You dot the primary carbons present in the structure. What does that mean? It means that looking at this structure, if you observe this carbon now, it's only connected to just 1 other carbon. So this is primary carbon. Then what about this one? It's also primary because it's only connected to just 1 other carbon. What about this one? Is primary. Then this one is also primary. Then this is what? Primary. So you dot the primary carbons. Alright? So now you try to link 2 possible dots to get the longest with just your initiative. If you link this to this, it will give you a very short chain. If you link this to this, another short chain. If you link this to this, it becomes 1, 2, 3, 4, 5. If you link this to this, it's short. If you link this to this, let's confirm. 1, 2, 3, 4, 5. Initially when we linked this, it was 5. So I can say that the longest possible chain here ought to just be 5. Because we can't get 6 if you check. If you link this dot to this dot is 1, 2, 3, 4, 5. So it means the possibility of you having any longest chain here ought to be what? 5 chain. That's 5 links, alright, in terms of the carbons. So it's best to just go with the horizontal to ease our stress. So this is the horizontal and this is actually the longest. So this chain, we are having all the bonds to be linked and they are all what? Single bonds. So that single bond is for the alkanes. Remember, the alkanes are known by their carbon-carbon what? Single bond. Alright? So this is an alkane member. How many carbons are you having in the parent? 5. That should be what? Pentane. So you should write it out. Pentane. Then another thing that you need to take note of is this. Any carbon that is not part of the parent chain should be circled as substituent. So you circle the whole of this, and you circle the whole of this, and you circle the whole of this because they are not part of it. And if you should sum up, share this one becomes CH3, which is methyl. This is also CH3, which is methyl. This is also what? CH3. Alright? So we have already identified each of them, they are methyl groups. Then the next thing, you number forward and backward. When you number forward, it becomes 1, 2, 3, 4, 5. That's forward. Then backward, 1, 2, 3, 4, 5. Backward. So now, if you bring these 3 methyl groups out, that's methyl, methyl to ease the stress, methyl, since we are having 3 of them, and methyl, the last one. If you go with forward direction, that's forward numbering, you know that these 2 will be for the first methyl and also for the one beneath. So 2 to this and 2 to that. So if you write it 2, 2, then why the last one is what? Is 4. If you are going with forward. Then for backward, we are only having just a single methyl in the second carbon. So backward 2. Then while this other 2, they are present in the fourth carbon, 4, 4. So what should determine the direction we are to go with would be the one that will give the least possible value when summed up. And what does that mean? If I sum up this forward now, it gives 8, because 2 plus 2 plus 4 is what? 8. But if I sum up this backward, it gives what? 10. So between 8 and 10, which one is smaller? 8. So it's best we should go with what? Forward. So we have to go with this. Alright? So instead of calling the name of this compound 2-methyl, 2-methyl, 4-methyl pentane, it's kind of clumsy. So what are you supposed to do? Just bring these 3 values out. That is 2, 2. Remember numbers from numbers, they are separated by comma again, 4, then 2 to 4 what? How many of the methyl groups are we having? 3. And you know that the word 3 has a prefix that you can use for it, which is what? Tri. So that becomes 2 to 4 trimethyl what? Pentane. So that's how you can go about the name of that. Let's quickly look at the other one. Looking at this, remember I told you to always dot the primary carbons. In this case, this is the primary carbon, so you can dot it. Then this is also another primary carbon you can dot, linked to only one carbon. Then this is also another primary carbon you dot. So let's try to link 2 possible dots in this case. If you link this to this, that becomes 1, 2, 3, 4, 5, 6. Let's confirm again. If you link this to this, because we are only having 3 dots there. So 1, 2, 3, 4, 5, 6. That's this 6. What about if you link this to this? Let's confirm. 1, 2, 3, 4, 5, 6, 7. So it's obvious that 7 is the longest. So you just group them like this. This is the longest. Then, of course, they are linked by single bonds, so you know the name. How many carbons are you having there? 1, 2, 3, 4, 5, 6, 7. So 7 is what? Hex. So you write your heptane based on the fact that they are linked by single bond. Alright? Then anything that is not part of that longest chain should be circled as substituent. So you circle the whole of this, and you circle this, you circle this, and you circle this. Alright? So this one can be summed up by having C2, if you want to represent it, H5, C2H5. And of course, you know what C2H5 is what? Ethyl. Ethyl. This is ethyl. Alright? Which is the second member of the alkyne. So if we number forward and backward, 1, 2, 3, 4, 5, 6, 7. Then backward, 1, 2, 3, 4, 5, 6, 7. It's obvious that we are to go with forward because of the fact that the first substituent here is present in carbon 2, the second is carbon 3, then while the third and the fourth is in carbon 4. But if you go backward, this will now be 4, which is the first 2 in backward now, then 5, 6. So it's obvious that the one that should be the smaller value should be the forward. Why? Because the whole of the substituents, they are concentrated towards the left. So that's the reason why the forward is very, very important, and we'll go with it. Alright, so let's bring out of the substituents to ease our stress. The first substituent there is what? Bromo, which is this one. So there's 2 attached to it. Then the second substituent is still what? Bromo, which is 3 bromo. 3 bromo. Then while this one, 4, we have 4 chloro. 4 chloro, and we also have the same 4 again for ethyl, so 4 ethyl. So how do we work with this? Since we are now having more than one substituent or different substituents, what are you supposed to do? You have to obey alphabet. Alphabet in that bromo starts with the letter B, chloro starts with the letter C, and ethyl starts with the letter E. So in terms of alphabet, the one that comes first should come first in the name. So it's obvious it's bromo. So you don't say 2 bromo, 3 bromo. No. Based on the bromos, they are of the same element. So you can actually bring the values out, which is 2, 3. Then since there are 2 bromos, it becomes dibromo because of the fact that there are 2. That's why we are working with that. Then the next is what? 4 chloro. 4 chloro. 4 chloro. Then what? 4 ethyl. 4 ethyl heptane. So that's the name of that structure. Alright. One thing that you just need to know is this before we even proceed to looking at naming of the alkenes and alkynes is this. If ethane is drawn like this, ethane, this is the structure of ethane. Remember that ethane is what? Is the second member of the alkenes, which is C2H6. C2H6. If I want to draw the member, corresponding member of alkenes, it should be ethene. And the reason I would have to lose 2 hydrogens is because of the introduction of another bond. Then if I want to get ethyne, it will now be something like the triple bonds, then H and H. The reason why I drew it like this is because this bond is making hydrogens not to be written above, and while this other one is making hydrogen not to be written below. Alright, so it is due to the level of bonds, the number of bonds present. That's why you call this unsaturated. You also call this unsaturated, meaning alkenes and alkynes are unsaturated. Only the alkanes are what? Saturated. And by saturated, it simply means that they are connected by carbon-carbon single bond, meaning hydrogens are just found everywhere. Alright, so let's see the naming of alkenes and alkynes. I will just treat them at the same time because they are somewhat related in that the pattern of naming the alkenes is the same pattern of naming alkynes. The only thing you do is just to change the in suffix to ein suffix. That's in the case of the alkynes. Now looking at naming of the alkenes and alkynes. Now they have somewhat similarity in terms of their naming in that they are both unsaturated. So in this case, unlike the alkanes, when you are naming the alkanes, you give preference or priority to the substituents. But in this case, you pay close attention to the carbons that are connected by the double or the triple bonds, as in the case of alkynes. So you give priority to them and you give least possible value to them, even when you are having substituents. Alright? So looking at this, without wasting much time, it's obvious that this to this is actually our longest chain. So you just take them out and then you number forward and backward 1, 2, 3, 4, 5, 6, 7. Then backward 1, 2, 3, 4, 5, 6, 7. Pay close attention to the carbons that are connected by the double bonds, irrespective of the fact that we are having a substituent here, which happens to be CH3. And you are aware that CH3 is what? Is methyl. So there's a methyl group there attached. But we give priority to the double bonds, that's the carbons that are connected by the double bonds. Now going by the forward numbering, we have 2, 3, then backward numbering 5, 6. So it's obvious that 2, 3 is smaller than 5, 6. So between 2 and 3, that's the next thing now. Between 2 and 3, which one would you go with? The lower one, which is 2. So you circle it. How many carbons can you have in the parent? There are 7. And 7 is what? Heads. So you now write your heads first, then you now attach that 2 to it, which is heads to what? In, because of the double bonds. And then remember that we have a methyl group attached, and we went with the forward numbering. So please, when you are going with a direction, go with it all the way. Don't forget that. So don't give 2 to methyl, because if you are giving 2 to methyl, it means you are going with the backward, and that's wrong. So you go with the forward. And since we went to the forward, it becomes 6 attached to methyl. So that should be 6 methyl, then heads 2 in. That's it. Then looking at this other one, this is obvious that our longest carbon chain is this one. And of course, when you number forward and backward, 1, 2, 3, 4, 5, 6. Then backward, 1, 2, 3, 4, 5, 6. Now going forward, looking at the carbons that are connected by the double bonds, is 2, 3, that's the first, and the second is 4, 5. Backward is also 2, 3, 4, 5. So we can go with any of the directions. So then we have substituents there. So now the next, between 2 and 3, which one is smaller? 2. Between 4 and 5, which one is smaller? 4. So how many carbons are you having in total? 6. That should be hex. Hex what? Hex 2, which is this 2. Then 4. Then how many of the double bonds? 2. So you use the word diene based on 2 double bonds. So that's how you can name this. Then let's quickly look at the alkanes. It's similar pattern. Looking at these alkanes, these are our longest. Then we number forward and backward. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then you pay close attention to the carbons that are connected by the double bonds. Sorry, the triple bonds rather. Then looking at this, we have 2, 3 as forward and 3, 4 as backward. So it's obvious it's 2, 3. Then between 2 and 3, which one is smaller than 2? Since we are going with the forward. So that becomes what? Pent, because of 5 carbons in total. So pent what? 2, not in, it will not be ine. Because of what? Of the carbon-to-carbon triple bonds. You know, triple bonds is for the alkynes. So that's how you go about it. Then if it were to be double bonds here, so that means what? Pent 2 in. You understand? Then looking at this one is very easy. Remember, you are giving priority to the carbon-to-carbon triple bonds in this case. So when you number forward and backward, 1, 2, 3, 4, 5, 6, 7, 8. Then backward, 1, 2, 3, 4, 5, 6, 7, 8. So going with the forward, your carbon-to-carbon triple bonds, they are seated in carbon 5 and carbon 6 in their positions. Then backward is 3 and 4. It's obvious 3 and 4 is smaller than 5 and 6. Then we are going with backward. So we should go with it all the way. 3 and 4, which one is smaller? You circle the 3. Alright? And then you have a methyl group. This is a methyl group attached. So first, the parent name ought to be what? How many carbons in total? 8. That should be oct what? 3 ine. Oct 3 ine. And then since we went to the backward, then 7 should be attached to the methyl. That becomes 7 methyl. 7 methyl, then oct 3 ine. Alright, so that's how you go about their names. So it's with my hope that everything I've explained, you've been able to understand it. If you are still finding some naming of structures difficult, you can drop it in the comment section. I'll be there to attend to your messages. Alright, so always stay glued to this channel, and don't forget, if you've not subscribed, hit the subscribe button. If you like this video, you can give a thumbs up and invite your friends as well, so that they will be particular of what you are enjoying in this channel. So remain blessed, and don't forget to always stay glued to this channel as more videos are on their way coming. Alright, thanks for watching, and God bless.